So you've deployed your new AI model. All the dashboards are green, the logs look perfect, everything seems to be running smoothly. But what if the biggest threat to your AI isn't some huge obvious crash, but a slow, silent decay that nobody even notices until it's way too late? Well, this is what we call a silent failure. And that's the big question here, isn't it? We're not talking about the kind of failure that sets off alarms and sends everyone scrambling. No, we're talking about something far more dangerous, a failure that hides in plain sight, slowly chipping away at trust and causing real damage, all while the system is telling you that everything is just fine.
So, yeah, that's our culprit, the silent failure. It's this bizarre situation where the system is up and running, it's giving you answers, but those answers just don't match reality anymore. It's not a bug that breaks the code, it's a bug that breaks the entire logic of the system. To really get it, we need to treat our AI like a patient and start with a proper diagnosis. First up, its environment.
All right, so the first thing we have to investigate is the world around the AI. See, models are trained on a snapshot of reality at a specific moment in time. But here's the thing, reality doesn't sit still. And when the world changes, even a perfectly good model can start to fail without making a sound. The first cause is something called data drift. Imagine you have a medical AI that's trained to spot lung disease. It's working great for years. But then a new factor comes into play, like widespread smoke from wildfires becomes the new normal. Suddenly, the kind of data it's seeing every day, the air quality, the types of symptoms people have, has shifted. The model is now looking at data it has never seen before, and its predictions start to get shaky, even though the basic science of lung disease hasn't changed at all. Okay, so this slide breaks down the two main ways reality can pull the rug out from under your model. On the left, you've got data drift, where the type of data coming in is different. The fraud model analogy is perfect. A model trained on pre-2020 shopping habits would be completely lost trying to figure out today's online spending. Then on the right, you have concept drift, which is even weirder. That's when the meaning of the data itself changes. What used to be a dead giveaway for spam, like sending thousands of emails at once, is now just Tuesday for a marketing department. The model's fundamental rules are suddenly out of date. Okay, so let's move on to our next diagnostic step. What if the problem isn't just that the world changed? What if the problem was there from the very beginning, baked right into the AI? These are like pre-existing conditions that can lead to a silent failure down the road. And a huge one here is overfitting. This is what happens when a model doesn't just learn the important patterns in its training data. It basically memorizes everything, including all the random noise and flukes. It becomes an amazing historian of past data, but a terrible prophet for the future because it can't generalize what it's learned to anything new. And the consequences, man, they are severe. We are not talking about some theoretical what-if scenarios here. IBM's Watson for Oncology gave out unsafe treatment advice. Zillow's algorithm for buying homes cost the company more than $300 million. And an Uber self-driving car failed to react properly to a person on the road, with tragic results. In every single one of these cases, the system was technically working, but it was silently, catastrophically wrong. Another one of these built-in problems is something called selection bias. This happens when the data you train your model on doesn't actually represent the real world. It's like, imagine you're studying a new diet, but you only look at the data from people who actually finished the whole program. You've completely ignored everyone who quit because it didn't work for them. Your model then thinks the diet is a miracle cure, when in reality, it's only looking at a biased, cherry-picked group of success stories. So our AI patient is struggling with a changing world and maybe some internal flaws from the start. But here's the crazy part. The main tool we use to check on its health, that accuracy score, can be totally misleading. It can give us a false negative, telling us everything's okay, when a disaster is actually brewing. You see this kind of thing all the time, right? Our new AI is 96% accurate. Wow, that sounds incredible. It sounds foolproof, like a system you can bet the house on. The short answer? Not really. That big, shiny accuracy score can be hiding a ton of problems, and relying on it alone is one of the quickest ways to fall victim to a silent failure. This quote from Forbes just nails it. That single number isn't the whole story. I mean, it tells you if the model got the prediction right, sure, but it tells you nothing about how confident it was, or if it even had any right to be that confident in the first place. And that brings us to this absolutely critical idea: model calibration. Put simply, it means a model's confidence should match its actual track record.
If your weather app says there's a 70% chance of rain, you'd expect it to actually rain about 7 out of the 10 times it makes that prediction. A badly calibrated model is like that friend who is always 100% sure about something and is wrong half the time. It's not just wrong, it's dangerously overconfident.
Okay, so we've got our diagnosis, we know about the changing environment, the potential flaws in the model, and the illusion of accuracy. Now for the big question, how do we fix it? Let's talk about the treatment plan, how to build AI that's resilient from the get-go.
So just to recap where we're at, the world is always changing, our model might have learned all the wrong things from the start, and its own confidence could be a total illusion. That's what we're up against.
So that's the million-dollar question, right? How do we get past just building models that seem to work and start building systems that we can actually truly trust with important decisions? Well, the treatment plan can't be just one thing. It has to be this multi-layered approach. First, you've got to stress test these things with wild black swan events they've never seen before. Second, we need to build AI that we can actually control, not just unleash. That means we have to do something called red teaming. Basically, you attack your own AI to find its weaknesses before someone else does. And of course, you have to be constantly monitoring for things like data drift and have a solid plan to retrain and adapt your models so they don't fall behind reality. And this leads to some really cutting-edge solutions, like something called the FAME framework. Now, this is a big shift in thinking. Instead of trying to prove the super complex AI model itself is perfect, which is basically impossible, you wrap this verifiable safety net around it. It uses simple, lightning-fast monitors to make sure the AI's behavior never ever violates a set of critical safety rules you've defined. And check this out, it actually works. In a test on a self-driving system, FAME caught over 93% of critical safety violations that were otherwise totally invisible. It literally turned the silent failures into loud, clear alarms. That's a total game changer. So all of this brings us to the prognosis. And honestly, it requires a new philosophy of care. We have to stop thinking about AI reliability as a one-time fix and start seeing it as a continuous process. At the end of the day, the prognosis is this. We're not trying to build perfect, infallible AI. That's not the goal, and it's probably not even possible. The real goal is to build resilient systems, systems that can adapt, that are accountable, and that are designed in a way that lets us verify their behavior and ultimately trust them. And that leaves us with one last big question to chew on. As these systems get more and more powerful and woven more deeply into our lives, how do we prove a system is safe when it's constantly learning from a world that is constantly changing? That's the challenge that's going to define the next era of AI.